So, like we just discovered, the size of the matrix matters if you're able to multiply the two matrices. So, it proceeds that not all matrices can be multiplied. So, to understand this, let's let A be an m by n sized matrix, and let B be an n by k sized matrix. The product AB can only be found if the number of columns of A, I'm going to highlight that here. This is the number of columns of A, is the same as the number of rows of B. The resulting matrix product will have a size of m by k. So that is the first and the last here. Okay, so let's just summarize that here. N has to be the same in the two matrices, meaning that the A matrix has to be the first matrix and the B has to be the second matrix, and those two values must be the same. In order to be able to multiply. Now, the M and the K, that is going to get us the product size. So once we multiply, we need to know what the new size is going to be, so the product size will be m by k. So before we actually get into summation multiplication, let's just figure out if we can actually multiply these two matrices, and if so, what is the size of the new matrix. So on our first example, we have a 2 by 3 example multiplied by a 3 by 3 matrix. Looking at this, are the columns of my first matrix equal to the number of rows in my second matrix? Well, yes, they are. They are the same. So that's like check. I got that taken care of. That means I can have a product. And what size is my product? Well, my product is going to be the number of rows of the first by the number of columns of the second product. So 2 by 3. All right, let's do this again. Our next matrix is a 3 by 3 matrix multiplied by a 2 by 3 matrix. And if you notice, these are the same two matrices. I just rearranged the order. Are the two middle values the same? The number of columns of A and the number of rows of B? Well, they're not the same. And because these are not the same right now, I can already say that this product is not possible. You can't do this product. You cannot multiply these two matrices together. It doesn't mean anything. Our next example, we have a 3 by 1 matrix multiplied by a 1 row and 3 column matrix. Are the two middle values the same? Yes. The number of columns of the first one and the number of rows of the second matrix are the same. Because they're the same, this means I can multiply. So what is the product? The product size will be 3 by 3, which is the number of rows of the first matrix by the number of columns in the second matrix. And our last one, we have a 1 by 3 multiplied by a 3 by 1. Notice these are the same matrices, I just rearranged them. I have 3's in the middle, which tells me that these two matrices are able to be multiplied. And that means the product will be sized 1 by 1, which is the rows of the first matrix by the columns of the second matrix. So this is going to help you determine if you can find the product or not. Next, we're going to go through the steps to actually multiply the two matrices. So step 1, we first have to decide if the two matrices can be multiplied, and then the size of the product matrix AB if they can be multiplied. Step 2, find the product of the elements of the first row and the first column, and then add those products together. Put this value in the first row, first column of the product matrix AB. That's a lot, okay? We're going to go back through that very carefully when we actually do our example. Step 3 says repeat steps 2 for each element in the product matrix AB. In general, to find the product elements in the ith row of A and the jth row of column, and then add those products. Put this value in the ith row and the jth row of the column of the product matrix AB. Now that again gets really crazy with the ith and the jth. It just means whatever value you're looking for, you're going to look in that row and that column of the first and second matrix. And again, this is going to make a little bit more sense when we actually do it. So for step 1, I'm looking at the sizes. We have a 2 by 3 matrix multiplied by a 3 by 3 matrix. Notice my 3 and the 3 are the same for the columns of the first matrix and the rows of the second matrix. Because those are the same, that tells me that I can have a product, and the size of my product is going to be a 2 by 3 matrix. Okay, so that tells me that I'm going to have a 2 rows by 3 column matrix. Now, I'm going to have a lot of work here, so I made this very large matrix, but then I'm going to reduce it into a more normal size matrix down below once I do all my work. But I really want to make sure you understand where all the values are coming from, so I'm going to make a big matrix so you can see all the work. And the other thing I'm going to do is I'm going to label these. This is my row 1 and row 2. This is my column 1, column 2, and column 3. I'm trying to be very specific so that you can understand why I'm getting my values where I'm getting them. You may be able to drop that in the future, but for now we're going to go ahead and use those values. So when I'm trying to find row 1 and column 1 product in my matrix, I need to follow step 2. Because this is in the first row and the first column, I'm going to use the first row in my first matrix by the first column in my second matrix. So notice I highlighted those values, and then I'm going to use those specific values. I'm going to multiply each of the corresponding elements. So 5 was the first in the row times 1, which is the first thing in the column, plus the second element in the row is 1 times the second element in the column is 6, plus the last element in the row by the last element in the column is -2 times -3. So then I can actually add those values together, and I'm going to do that in a little bit here. Now I'm going to erase some of these highlights because I need you to understand we're going to keep using those rows over and over and over again. Okay, for the second element, I am looking for the element in row 1 and column 2. Because the blue highlighted area is in row 1 and column 2, I'm going to highlight row 1 of my first matrix and column 2 of my second matrix in order to get my first row, second column value. So now I'm going to take the first element, which is 5, times the first element of the column, which is 7, plus the second element of the row, which is 1, times the second element of the column, which is -1, plus the third element of the row by the third element of the column, which is -2 times -5. So next I'm looking for the first row, third column. I'm going to highlight that in green. So I'm going to erase my blue highlights. Because I'm looking for the first row and the third column, I'm going to highlight the first row and the third column. And now I can go back and multiply those values. So we have 5 times 8, which is the first elements, plus 1 times 2, which are the next two elements, and then -2, which is the third element in the row, by 3, which is the third element in the column. All right, let's do this again. Now I'm looking for the element in the second row, first column. So I am going to highlight the second row of my first matrix and the first column of my second matrix. Then I can go and grab those values. 3 times 1, which is the product of the first two elements, plus -7 times 6, which is the product of the next two elements, plus 4 times -3, which is the product of the last two elements in the row and corresponding column. Next, I'm looking for the element in the second row, second column. So I'm going to highlight the second row and the second column of my first and second matrix respectively. So I take the product of the first elements, which is 3 times 7, plus the product of the next two elements, which is -7 times -1, plus the product of the third element, which is 4 times -5. And then my last one, in the second row, third column, I'm going to highlight my second row and the third column. And then I can find their products. 3 times 8, which is the product of the first two elements, plus -7 times 2, which is the product of the next two elements, plus 4 times 3, which is the product of the last two elements. So now I can get my calculator out. So now I'm going to type it in my calculator. 5 times 1 plus 1 times 6 plus -2 times -3. And that's going to get me 17. For our next element, first row, second column, I'm going to plug in the values. And that gets me 44. And when I plug in the last one, I'm getting 36. Why don't you pause the video and see if you can get the last three values on your own. You should have got -51, 8, and 22 for the last elements of the row. So this is how you matrix multiply.